Hey everyone, thought we'd maybe try and do a textbook question. I know that number 17 maybe wasn't on our list, but it's actually a pretty nice question. So you get the sand dumped on a conveyor belt at a rate of 1.2 cubic meters per minute. So we know we're going to differentiate with time because it's per minute. And it's saying it's forming a conical pile, and the base and the diameter, or the base diameter and the height are always equal. How fast is the height kind of growing when the pile is 3 meters high? So the reason this is a nice question is that you're told your moment in time you're going to have a 3 meter high pile. So if you think back to some of our other cone questions, volume is 1/3 pi r squared h. That's three variables, but we're only talking about change in volume and change in height. So the first thing we have to do again is get our function. So it's only talking about volume and talking about height. So inside the problem, when it said the diameter and the height were equal, you have a relationship now that you can talk about in terms of radius and height. So the radius is half the height. That goes in for r squared. You simplify 1/2 h squared. It's 1/4 h squared. Do some more magic math, and suddenly you have a volume formula that has nothing to do with radius. It only has to do with volume, and it has to do with height. So this is the volume of a cone when the diameter and the height are equal to each other. So that's step one. We've got a function now that have the rate and variables equal to each other. The next thing you want to do is put the rates into the problem, and then the last thing you're going to do is actually solve the problem for the moment in time. So we got volume dv dt, height cubed is 3h squared, the 1/12 pi, that's just constant. So again, 3h squared with dh dt. Simplify your fraction, 3/12 is a quarter. And now you've got how is the volume changing as the height changes. And to find the height change, you also need to know the height. So it was awesome that they gave you the height was 3. Plug in, simplify, and solve, and you can answer in meters per minute, 0.17 meters per minute, or we can just say it's growing at a rate of 17 centimeters per minute when the pile is 3 meters high. So that's a quick run through of question number 17 from our textbook.